Hello dear students, in the last class we discussed the series combination of resistors and what is the formula used to find the total resistance in the series combination, that is Rs is equal to R1 plus R2 plus R3 if three resistors connected in series. Rs is equal to R1 plus R2 plus R3. Okay, if three resistors are connected in series, their total resistance can be determined by Rs is equal to R1 plus R2 plus R3. What is R1? R1 is the resistance of the first resistor, R2 is the resistance of the second resistor, and R3 is the resistance of the third resistor. For example, if 1 ohm, 2 ohm and 3 ohm are connected in series, then what is the total resistance of 1 ohm, 2 ohm and 3 ohm in series combination? That is, Rs is equal to R1 is supposed to be 1 ohm, R2 is 2 ohm and R3 is 3 ohm. Then the total resistance of the series combination of these three resistors is 6 ohm. Okay. ಒಂದು ವೇಳೆ 1 ಓಮ್ 2 ಓಮ್ ಮತ್ತು 3 ಓಮ್ ರೆಜಿಸ್ಟರ್ಸನ್ನು ನಾವು ಸೀರೀಸ್ನಾಗ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೇವೆ ಅಂದ್ರೆ ಅವ್ರದ್ದು ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗುತ್ತೆ ರೀ ಇಲ್ಲಿ 6 ಓಮ್ ಆಗುತ್ತೆ. ಹೌದಾ? ದೆನ್ ಇಫ್ ದೇರ್ ಆರ್ 4 ರೆಜಿಸ್ಟರ್ಸ್ ಕನೆಕ್ಟೆಡ್ ಇನ್ ಸೀರೀಸ್, ದೆನ್ ವಾಟ್ ಈಸ್ ದಿ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಟು ಫೈಂಡ್ ದಿ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದಿ 4 ರೆಜಿಸ್ಟರ್ಸ್ ಇನ್ ದಿ ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್? ಸೊ ದಟ್ ಈಸ್ Rs is equal to R1 plus R2 plus R3 plus R4. Okay, it is the formula used to find the total resistance of 4 resistors which are connected in series. Okay, so ಇಲ್ಲಿ 4 resistors ಯಾವ ಥರ ಕನೆಕ್ಟ್ ಆಗ್ಯದ್ರಿ? ಸೀರೀಸ್ನ ಕನೆಕ್ಟ್ ಆಗ್ಯದ. ದೆನ್ ಆ 4 resistors total resistance ಕಂಡುಹಿಡಿಯೋ ಫಾರ್ಮುಲಾ ಯಾವುದು? Rs is equal to R1 plus R2 plus R3 plus R4. Okay, now if there are n number of resistors are connected in series, then what is the formula used to find the total resistance? So that is Rs is equal to R1 plus R2 plus R3 plus and so on Rn and so on Rn. Okay, if n number of resistors are connected in series, their total resistance can be determined by the formula, that is Rs is equal to R1 plus R2 plus R3 plus and so on Rn. Okay, now next, if each resistor having the same resistance, then what is the formula used to find the total resistance in series combination? ಅಂದ್ರೆ ಪ್ರತಿ ರೆಜಿಸ್ಟರ್ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಸೇಮ್ ಆಗಿತ್ತಂದ್ರೆ ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ಬೇಕು ರೀ ನಾವು? ಅಂದರೆ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು? ಓಕೆ, ಸೊ ಸಿಯರ್ ಇಫ್ R1 is equal to R2, that is equal to R, and here R1 and R2 are connected in series and each resistor having the resistance R. ಎಷ್ಟು ರೆಜಿಸ್ಟರ್ಸ್ ಅದಾವ್ರಿ? ಇಲ್ಲಿ 2 ರೆಜಿಸ್ಟರ್ಸ್ ಅದಾವು and these 2 resistors are connected in series and each resistor having the resistance R. Then what is the formula used to find the total resistance of the 2 resistors connected in series? That is Rs is equal to R1 plus R2, R1 plus R2. See here. Then R1 is R and R2 is also R because resistance of each resistor is same, that can be taken as R. Now it is R plus R, then it is 2R, then it is 2R. Then what is the formula used to find the total resistance of the 2 resistors having the same resistance in series? That is Rs is equal to 2 into R. Okay, now if there are 3 resistors having the same resistance connected in series, then what is the total resistance? So that is Rs is equal to R1 plus R2 plus R3 because how many resistors connected in series? 3 resistors connected in series and each resistor having the same resistance. So resistance of the first resistor can be taken as R, resistance of the second resistor taken as R, and resistance of the third resistor also taken as the R. Then R plus R plus R, that is 3R, that is 3R. Okay, now here what is R? R is the resistance of each resistor. R ಅನ್ನೋದೇನ್ರಿ ಇಲ್ಲಿ ಪ್ರತಿ ರೆಜಿಸ್ಟರ್ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಗುತ್ತೆ. ಓಕೆ, now for example, if 3 resistors having the resistance 1 ohm connected in series, then what is their total resistance? How many resistors? 3 resistors having the resistance 1 ohm and they are connected in series. Then what is the total resistance of those 3 resistors? That is Rs is equal to 3 into resistance of each resistor is how much? That is 1 ohm. 3 into 1, then it is 3 ohm. So let us verify this one. So Rs is equal to R1 plus R2 plus R3. How many resistors connected in series? 3 resistors connected in series and each resistor having the resistance how much? 1 ohm. Then 1 plus 1 plus 1, then it is 3. Then it is 3 ohm. Then, so when we have to use this formula? Only when if there are 3 resistors having the same resistance connected in series, then their total resistance can be determined by Rs is equal to 3 into R. Now, if there are n number of resistors having the same resistance connected in series, then how to find their total resistance? If n number of resistors having the same resistance which are connected in series, how to find their total resistance? That is Rs is equal to n into R. N into R. Here n is nothing but the number of resistors and R is nothing but the resistance of each resistor, where n is the number of resistors. N is the number of resistors and R is the resistance of each resistor. Resistance of each resistor. See, if there are 10 resistors connected in series having the resistance of 2 ohm, then what is the total resistance of those 10 resistors? How many resistors are said here? 10 resistors. N is equal to 10. And each resistor having the resistance how much? 2 ohm. Then what is the total resistance of 10 resistors in series now? So that is Rs is equal to, by using this formula, N is 10 and R is 2, then 10 into 2, that is 20 ohm. That is 20 ohm. So hence Rs is equal to 20 ohm. ಈಗ ನೋಡ್ರಿ, ಸೊ 10 ರೆಜಿಸ್ಟರ್ಸನ್ನು ನಾವು ಸೀರೀಸ್ನಾಗ ಕನೆಕ್ಟ್ ಮಾಡಿವಿ. ಪ್ರತಿ ರೆಜಿಸ್ಟರ್ದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಾದ್ರಿ? 2 ಓಮ್ ಅದ. ಅಂದ್ರೆ ಆ 10 ರೆಜಿಸ್ಟರ್ಸ್ದು ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಾಗುತ್ತೆ? 20 ಓಮ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ 2 + 2 + 2 + ಆ್ಯಂಡ್ ಸೊ ಆನ್ ಅಪ್ ಟು 10. ಓಕೆ, ಸೊ 2 + 2 + 2ನ ನೀವು ಕೊಡಿಸ್ಕೊಂತ ಹೋದ್ರೆ ನಿಮ್ಗೆ ಎಷ್ಟು ಸಿಗುತ್ತೆ ರೀ? ಇಲ್ಲಿ 20 ಓಮ್ ಸಿಗುತ್ತೆ. ಓಕೆ, ನಾವು so this is the formula used to find the total resistance of the resistors connected in series having the same resistance. And one more thing, remember, the equivalent resistance or total resistance in this series combination is greater than the individual resistance. See here, Rs is equal to, let us take R1 plus R2 plus R3. R1 plus R2 plus R3 here. Now see here, the total resistance in the series combination is greater than the individual high resistance. ಈ 3 ರೆಜಿಸ್ಟರ್ಗಳು ಕೊಟ್ಟಿವಿ, ಆ 3 ರೆಜಿಸ್ಟರ್ದಾಗ ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಿರುತ್ತೆ ನೋಡ್ರಿ, ಅದಕ್ಕಿಂತ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೆಚ್ಚಾಗಿರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಲೆಟ್ ಅಸ್ ಟೇಕ್ R1 is equal to 1 ohm, R2 is equal to 2 ohm and R3 is equal to 3 ohm. R3 is equal to 3 ohm. And here, which is the high resistance? 3 ohm is the high resistance. In the given 3 resistances, 3 ohm is the high resistance, and here Rs must be greater than 3 ohm. So let us calculate this one. Rs is equal to 1 plus 2 plus 3. Then it is how much? 6. Then Rs is greater than 3 ohm, means Rs is greater than R3. Rs is greater than R3. ಅಂದರೆ ಇದ್ರ ಅರ್ಥ ಏನಂದ್ರೆ ರೀ, ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಯಾವಾಗಲೂ ಏನಿರ್ತಂದ್ರೆ ಕೊಟ್ಟಂಥ ರೆಸಿಸ್ಟೆನ್ಸಸ್ದಾಗ ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಿರ್ತಲ್ಲ ರೀ, ಅದಕ್ಕಿಂತ ಏನಿರುತ್ತೆ? ಹೆಚ್ಚಾಗಿರುತ್ತೆ. ಈ 3 ರೆಸಿಸ್ಟೆನ್ಸಸ್ ಕೊಟ್ಟಿದ್ದೇನೆ, 1 ಓಮ್, 2 ಓಮ್ ಮತ್ತು 3 ಓಮ್. ದೆನ್ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗಿರ್ಬೇಕು ಇಲ್ಲಿ? 3 ಓಮ್ಕಿಂತ ಹೆಚ್ಚಿಗಾಗಿರ್ಬೇಕು. Total resistance of 1 ohm, 2 ohm and 3 ohm is how much? 6 ohm, and 6 ohm is greater than 3 ohm. Hence Rs is greater than R3. In words, total resistance in series combination, total resistance in series combination, total resistance in series combination is greater than individual high resistance. ಅಂದ್ರೆ ಕೊಟ್ಟಂಥ ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಈ ಮೂರು ರೆಸಿಸ್ಟೆನ್ಸಸ್ ಕೊಟ್ಟಾರ, ಅದರೊಳಗಡೆ ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್ಗಿಂತ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ ಹೆಚ್ಚಾಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ 3 ohm ಈಸ್ ದಿ ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇನ್ ದಿ ಗಿವನ್ 3 ರೆಸಿಸ್ಟೆನ್ಸಸ್. Hence the total resistance is greater than this high resistance, individual high resistance. Okay, and one more point. In series combination there is a potential divides across the each resistor but current remains same. Series combination ದಾಗ ಏನು ಸೇಮ್ ಇರುತ್ತೆ ರೀ, ಕರೆಂಟ್ ಸೇಮ್ ಇರುತ್ತೆ, ಬಟ್ ವೋಲ್ಟೇಜ್ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಡಿವೈಡ್ ಹಾಕ್ಕೊಂತ ಹೋಗುತ್ತೆ. ಇನ್ series combination current is same, means current through the each resistor is same. Current through each resistor is same. Current through each resistor is same, but potential divides across the each resistor. Potential divides across each resistor. Across each resistor. Now see here, according to Ohm's law, then V is equal to I into R. In series combination, what is same means what is constant? Current is constant. Hence I will write V is directly proportional to R. So potential drop across each resistor is directly proportional to resistance. Okay, let us consider an example. Let us take an example. So potential drop across the resistor in the series combination depends on its resistance value. See, if first resistor having the resistance 1 kilo ohm, second resistor having the resistance 2 kilo ohm, and third resistor having the resistance 3 kilo ohm, and the current flowing through each resistor can be taken as 1 milliampere. I can be taken as 1 milliampere. And the applied potential difference across the combination of the series combination of R1 and R2, R1, R2 and R3 is 6 volt. ಎಷ್ಟು potential difference apply ಮಾಡ್ರಿ series combination ಗಿಲ್ಲಿ 6 volt apply ಮಾಡ್ರಿ. Okay, see here. Let us draw the diagram. Then this is the series combination. The series combination of how many resistors? 3 resistors. And resistance of the first resistor is how much? 1 kilo ohm. And resistance of the second resistor is 2 kilo ohm. And resistance of the third resistor is 3 kilo ohm. And current flowing through the series combination is how much? 1 milliampere. Current is 1 milliampere. And the potential difference applied across the combination of 3 resistors is 6 volt. That is how much? 6 volt. Then here the potential drop across the resistor that depends on its resistance value. Then potential difference across 1 kilo ohm, that can be taken as V1. Potential drop across 2 kilo ohm, that can be taken as V2. And potential drop across 3 kilo ohm, that can be taken as V3. And see here, V3 is greater than V2 and V2 is greater than V1, because potential drop across the resistor that depends on its resistance value. So which resistor having the high resistance here? Third resistor having the high resistance. Hence there is a more potential drop. Okay, so let us calculate that one. V1 is equal to I into R1. I into R1. So what is the value of current here? The current flowing through the resistor R1 is 1 milliampere. That is 1 into 10 to the power of minus 3. Then resistance of the first resistor is 1 kilo ohm. Then that is 1 into 10 to the power of plus 3. So 10 to the power of minus 3, 10 to the power of plus 3 get cancelled. Then 1 into 1, that is 1 volt. Then what is the potential divide across the 1 kilo ohm here? Means potential drop across the 1 kilo ohm 1 volt. ಎಷ್ಟಾಯ್ತು ರೀ ಇಲ್ಲಿ 1 ವೋಲ್ಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನೋಡ್ರಿ ಮಿಲಿ ಅಂದ್ರೆ 10 to the power of minus 3, ಕಿಲೋ ಅಂದರೆ 10 to the power of plus 3. ಓಕೆ, ನೆಕ್ಸ್ಟ್ potential across means potential difference across the second resistor. ಇಲ್ಲಿ ಅಪ್ಲೈಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಸ್ ಏನಾಗುತ್ತೆ ರೀ, ಡಿವೈಡ್ ಆಕೊಂತ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ಬಿಕಾಸ್ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಥ್ರೂ ಈಚ್ ರೆಸಿಸ್ಟರ್ ಇಸ್ ಸೇಮ್, ಬಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿವೈಡ್ಸ್ ಅಕ್ರಾಸ್ ಈಚ್ ರೆಸಿಸ್ಟರ್ ಬಿಕಾಸ್ ಆಫ್ ಇಟ್ಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ. ನೌ V2 is equal to I into R2. Then again I is 1 into 10 to the power of minus 3. Then R2 is 2 into 10 to the power of plus 3. Hence these two get cancelled. Then 2 into 1, that is 2 volt. Next, potential difference across the third resistor, that is V3 is equal to I into R3. Then we will get, this is 3 volt. Substitute the value. So I is 1 into 10 to the power of minus 3 and R3 is 3 into 10 to the power of plus 3. 10 to the power of minus 3, 10 to the power of plus 3 both get cancelled. Then 3 into 1 is 3 volt. So the potential difference across the high resistance is maximum. Okay, ಅಂದ್ರೆ ಇಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಈಗ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್ ಹಾಕೊಂತ ಹೋಗ್ತಲ್ರಿ, ಆ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್ ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ ಅಂದ್ರೆ ಆ ರೆಸಿಸ್ಟರ್ದು ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ. ಓಕೆ, ಇಲ್ಲಿ ಕೊಟ್ಟಂಥ 3 ರೆಸಿಸ್ಟರ್ಸ್ ಒಳಗಡೆ ಯಾವ ರೆಸಿಸ್ಟರ್ದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೈ ಐತ್ರಿ ಇಲ್ಲಿ? ಸೊ ಥರ್ಡ್ ರೆಸಿಸ್ಟರ್ದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೈ ಐತಂದ್ರೆ ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿರುತ್ತೆ. ಅಂದ್ರೆ ಎಷ್ಟು ಐತ್ರಿ ಇಲ್ಲಿ? 3 ವೋಲ್ಟ್ ಐತಿ. ಇಲ್ಲಿ ಎಷ್ಟೈತಿ? 2. ಇಲ್ಲಿ ಎಷ್ಟೈತ್ರಿ? 1. Hence 1 plus 2 plus 3, that gives applied potential difference 6 volt. Okay, so this is all about the series combination of resistors.